Okay. Online students, can you hear me clearly? Online students, can you hear me clearly? Confirm with the message. Students in the Zoom and in the YouTube live. Confirm with the message whether you can hear me clearly or not. All right. Okay. So hope you can hear me clearly. And if you have any disturbance, just let us know. Okay. I mean, if a sudden disturbance occurs, like some kind of a sound issue, if the sound is not enough, or any kind of a lagging or any kind of issue, just let us know as soon as possible. Okay. Now is it clear? Now is it clear? Okay. And YouTube students in the YouTube live, what about you? Can you hear me clearly? Okay. Sure. Okay, so then let's start the session. Okay, let's start the session today. To, camera. Today the main target is, I mean, today is not a very, it's not a very important session or anything like that. We originally was trying to do this online, but anyway, since I'm here doing it, I'm gonna stream it at CCG. That's why we decided to do it physically too. But anyways, majority of the students are online. But anyways, even if we have to, I mean, we due to the conditions now, it looks like we may have to shift into online in the future. Okay, we don't know. But anyways, even if we move to online, I still stream everything from CCG. Okay, so any student who's willing to come physically to the institute can come to the institute, even if we have to shift into online mode. Okay, we are not shifting into online mode, but this is a nice country, right? So we don't know when we have to shift into online, but even if we shift to online, still I'm anyways gonna do all the classes at the CCG from from here, so you can come physically if you need. And I think most of the students are not new students, right? You were the students who came like within the last week or something like that. So we usually do these kind of sessions again and again. That means now we usually from the first day we start with A level content. I'm not gonna stay with the O level content until students come to the class. I mean, because we give a promise that we are gonna finish the syllabus 6 months before the exam, so we can't keep that promise. If we stay in O levels, if we stay stuck in O levels for few weeks until students come, then if we start A levels, then again it's too late. Okay, every delay counts here. Okay, every delay counts when it comes to A levels. So we never do that. Okay, we never do that. What we usually do is from the first day we didn't have a major orientation session too, right? We just started teaching from the first day. Okay, I talked for like 30 minutes, then we started and we played with the Starlink for like 30 minutes. Everything went down. Kind of fun stuff happened, but anyways, after like 45 minutes we started learning, and from that day onwards we started A level content. Okay, so the students who came in the next weeks, the weeks after that, definitely have missed a certain part of the A level content. So I usually do these kind of sessions again and again and again, so that the students won't miss any part from A levels. Okay, that is the target. So today what we are going to do is we are going to teach things again. Okay, we are going to teach things again. Teach the things that you have missed. Check the count there. We are gonna teach the things again, but I mean it won't take a very long time. Why? Every week we do a extra tute, some Olympiad questions. some physics content. So I'm going to remove all the other parts and do the content that is in the syllabus only, okay? So although I'm going to cover 2 or 3 weeks of content today within 4 hours, it's not that difficult because as I mentioned, every day we do different stuff. I'm going to remove all the different stuff and do only the parts in the A-level syllabus, okay? So that you can catch up with the class from next week. From next week, you can stay in the class easily without any issue, okay? That is the target, okay? From next week, you can stay in the class without any issue. And we usually do this again and again and again. Because I mean, the reason is I personally know that when it comes to A-levels, you miss 1 or 2 weeks in the previous days, not a big issue. Still you miss some stuff. That means it's not like in O-levels. Lessons are not separate. Everything is connected. So you miss 1 week at the middle. Then from next week onwards, you can't understand very small stuff here and there. You don't see that as a major issue. But that small stuff that you don't understand again accumulate. And now you won't understand some medium-sized stuff after like few months. And now, as a result of not understanding those stuff, after like 6-7 months, you can't understand full lessons, okay? Because it accumulates, okay? You miss 1 week due to that week content. In the upcoming weeks, you understand everything perfectly, but here and there you miss some stuff. So all those stuff you miss, they accumulates. Then they accumulates, and it becomes a huge content so that after a few months, even you don't know what happened, okay? Clear? For us, it was quite complex. Why? We didn't have recordings, okay? I'm just before COVID. I'm 2019 A-level. We didn't have something called recording or online streaming, okay? Clear? Only after COVID, it started, okay? That's why even this crisis will end up as a good thing, okay? Every crisis ends up well usually, okay? So for 2019 A-level, we didn't have recordings. We didn't had online streaming. You miss the class, that's all, okay? But one of the best thing was, as a result, we never missed a class, okay? We were always there. Why? You miss the class, there's no way to catch that up, okay? None of the teachers have recordings, none of the teachers are live streaming, nothing on YouTube. So you miss a class, you have no idea what happened on that day, okay? From next week onwards, you somehow have to manage. But now, you can't miss a class, okay? Yeah. You have a full kind of issue or any kind of issue, you join online. Or you miss the class, you request for the recording, and you don't even have to request the recording, we put it in the group, then you watch that later. So nowadays, there's no way of you missing a class. But then why am I doing the session? Even you know and I know that you're not going to watch the recordings, right? Yeah. So that's why this session, okay? So let's move forward. Online students, hope you're fine, right? So let's move forward then. Go to your tudes. Hope the students got the tudes, okay? And for online students, tudes are available in the resources, right? Tudes will be available in the resources, and provide the tude in the groups. Okay, if you can't find the tude, let us know in the Zoom chat or in the YouTube live chat. And like for tude delivery, I'll put a number, but we called and checked all the students. I think out of like 800, 900 online students, only around 20, 25 students said that they didn't receive the tutor. Okay, for online students, we call for like all 800, 900 online English medium students like yesterday and day before that, and checked. I think out of that 800 or 900, we only like 20 to 30 students said that they didn't receive the tutor, and we are sending the tutors again for them. The majority of the students should have received the tutors by now. But if you still haven't received the tute, or if you are entirely new to the class, okay? Or if you are entirely new to the class, I'll provide you a number here and tute courier information, then you will receive the tute within like 3-4 days, okay? It used to be 3 days. Now with fuel kind of issues, I don't know. But at least in 1 week, you will receive the tute, okay? So today after the session, our people start packing the tutes, okay? So we are very quick with these kind of stuff. So today after the class, our people will start packing the tute. So we'll deliver it to post office by tomorrow, and within 3 days after that, ideally you should receive the tickets, online students. Okay, clear? So let's move forward. Okay, starting with the first concept, go to the first page of your tute. Okay, go to the first page of your tute. Measuring instruments. Measuring instruments. Sorry, actually we are starting with measurements. Measurements. So when it comes to measurements, first we start with defining what do we measure by measurements. What do we measure by measurements? We measure physical quantities, okay? We measure physical quantities by measurements, okay? Then what is a physical quantity? What is a physical quantity? Physical quantity, okay? Physical quantity is something, again, that can be measured directly or indirectly, okay? Physical quantity is something that can be measured directly or indirectly. Clear? That means the length, temperature, mass, light intensity, sound intensity. All of these are measurements, okay? All of these can be measured. So all of these are physical quantities, okay? Clear? Anything that can be measured directly or indirectly is a measurement. Is a physical quantity, okay? Anything that can be measured directly or indirectly is a physical quantity, okay? Now, when it comes to physical quantities, like we have the SI unit system, okay? We have the SI unit system and other unit systems too. That means any physical quantity have two things. Any physical quantity have two things. What are they? The magnitude and the unit, right? Magnitude and the unit. Any physical quantity has two things, magnitude and the unit. Here, there should be a magnitude and a unit. So there are different ways of measuring this magnitude. It's a different story. But when it comes to this unit, okay, when it comes to this unit, okay, when it comes to this unit, we have to like properly define these units. Why? In the early days, there were no proper definition of these units, right? For an example, we used to consider the mass of the king as a unit of measurement, right? Clear? And the length from here to here, length from here to here, okay? And again, different kind of random stuff that belongs to certain areas used to be measurements, right? Used to be units. Clear? So previously there were no very specific definition of units, okay? They were divided, okay? Divided within different regions, okay? But after that, I mean, countries like USA still use things like pounds, like that, right? But after these all invading kind of stuff by Napoleon Bonaparte, these kind of people, they conquered like 50% of the living world, right? Okay, people like Napoleon Bonaparte, they conquered like 50% of the living world. Okay, 50% of the living world belong to them in certain times. Okay, now there's a problem. Why? You measure something in that area and you bring it to this area. Now the units are not matching. Okay, now you can't do global trade. So they needed what? They needed a proper definition of units. Clear? For that, they introduced the SI unit system. Okay, for that they introduced the SI unit system. Okay, SI unit system means all the measurements that you know now. That means things like meters, kilograms, these kind of stuff. Okay, this is SI unit system. Okay, but still there are some countries and specific industries that use their own measurements. Okay, for an example, For an example, still USA use pounds for many stuff, right? Okay. When they measure stuff, they still use units like pounds. Okay. They are not, I mean, they ideal don't like to change that. I mean, because they have a feeling like if they confirms into SI unit system, that they confirm into world. So USA people, right? They always create all the problems. Okay. So now still they are not 100% SI. Okay. I think USA is the only country now that is not 100% SI. Few other countries are there. Okay. But like, I mean, even I don't know whether you have heard this or not. There was a very popular incident. Mars climate orbiter. Mars climate orbiter was a satellite sent to Mars. Okay, to orbit around Mars. It was $1 billion project. It was crashed. Okay, it was crashed onto Mars because it was a joint project between Russia and USA. Okay, it was a joint project between Russia and USA. And the main problem was, Russia had the ground information. As I remember, Russia had the ground information. That means they transmit all the signals. USA built the satellite. This was transmitting in SI. This was transmitting in SI. Okay. This was receiving in other local units. Okay. Because the satellite was built in USA. This is a very popular incident. Okay. Go and search Mars Climate Orbiter. The satellite was receiving things from their own units, and the ground station was transmitting in SI. So when you send 5, or when you send the information 5, this guy sends 5 kilogram, this guy thinks it's 5 pounds. Entirely different. Okay. So all the units, all the judgments were collapsed. Okay, all the judgments were collapsed, and it landed onto Mars. Okay, so these kind of very major scenarios has happened. Okay, these kind of very major scenarios has happened due to this, like, non-conformity of units. Okay, so unit should be confirmed. That means everyone should be using the same unit. Okay, so now uh, the next one is well, අරකට යන sounds උත් වැඩි කරන්න. So the next one is, now as a result we needed the SI unit system. Okay, as a result we needed a proper unit system with a proper confirmation. Okay, we needed the proper unit system with a proper confirmation. That's why we developed SI unit system. Okay, so today's first topic is about SI unit system. Okay, today's first topic is about SI unit system. Then talking about this SI unit system, we first divide physical quantities into 2 types in this SI unit system. Okay, we divide physical quantities into 3 types in this SI unit system. Go to your tute. First one is fundamental physical quantities. First one is fundamental physical quantities. Then the next one is derived physical quantities. Next one is derived physical quantities. The last one is supplementary physical quantities, supplementary physical quantities. So ideally, in the main class, we usually, I mean, everything you have to know and you have to write is included in your tutor, okay? But ideally, we usually write a short note in the main class that I'm not going to do today because this is a revision session, okay? Usually in the main class, while having all the content in the tute, we create a small short note too that I'm not going to do today because today we are doing a revision session. So now, moving into these three types, fundamental, derived, and supplementary. What are fundamental physical quantities? Fundamental physical quantities are the physical quantities. Fundamental physical quantities are the physical quantities that are independent, or that can be measured directly. That's all. That means fundamental physical quantities are not permutations of anything else. They cannot be divided into further physical quantities. They can only be measured directly. Like what? For an example, take area. Take area. What is area? What is area? Length into length, right? Or length into width. Area is length into width. Clear? What is density? What is density? Mass over volume. Density, mass over volume. Clear? But now tell me, what is length? What is length? Length is just length, right? Clear? Length is just length. So it's something direct. You can't tell length is this into this, so this divided by this, so anything like that, right? Length is just a natural physical quantity that you can directly measure. That's all. You either measured it directly, that's all. Clear? Again, what is mass? Mass is mass, right? That's all. Clear? So these kind of stuff, we call them fundamental physical quantities. Clear? Natural stuff. Okay? Natural or direct stuff. There are 7 fundamental physical quantities like this. Okay? There are 7 fundamental physical quantities like this. What are they? I'm not gonna write everything. Okay? I'll write roughly. First one is length. First one is length. Measured in meters. Measured in meters. Next one is mass. Next one is mass. Measured in kilograms. Measured in kilograms. The next one is time. Time. Measured in seconds. Next one is thermodynamic temperature. That means ideally temperature. Temperature. Thermodynamic temperature or the temperature. Measured in kelvins. Measured in kelvins. Then electric current. Electric current. Electric current measured in amperes. Amount of substance. Amount of substance. I'll just write it as amount. Amount of substance measured in moles. Measured in moles. Luminous intensity. Luminous intensity. Measured in candela. So what are these physical quantities? What are these physical quantities? What is length? That you know, right? Mass, again, I don't have to explain. Okay. Time, again, a direct physical quantity. Okay. Temperature, again, a direct physical quantity. But what was the unit that you used to use for temperature? Celsius, right? But that is not the main SI unit for temperature. Okay. Celsius is not the main SI unit for temperature. It is Kelvin. Okay. It is Kelvin. Okay. Then current in amperes. Okay. Current measured in amperes. Amount of substance. Current, you know, right? Current measured in amperes. Okay. Current. This is also a direct physical quantity. Okay. This is also a direct physical quantity. Then the next one. amount of substance. Amount of substance. What is the amount of substance? How many tables are here? Okay. This stuff you anyways know, right? Clear? What is amount of substance? How many tables are here? How many atoms are there in a particle? How many electrons are there in atom? How many? That unit, the unit called how many of things? It's a direct thing, right? I mean, if you need the number of tables here, you just count the number of tables. That's all, right? So it's also a direct measurement, right? It's also a direct measurement. Okay. If you need the number of tiles here, you just count them, right? There's no other way of getting that, right? See, these are direct measurements, clear? So the amount of substance, amount of something is also a direct measurement. So it is also a fundamental physical quantity. You know this unit, right? Moles, you had this in all of us, right? Okay, measured in moles. Okay. Then the next one, this is the only entirely new thing, okay? This is the only entirely new thing, luminous intensity. Luminous intensity measured in candela. Okay, measured in candela. What is luminous intensity? The intensity of light coming out of these bulbs. I mean, luminous intensity is very common in these projectors. Okay, they charge for the bulb of the projector based on the luminous intensity it can provide. Okay, how much light or how intense light can it provide? Okay, clear? That is luminous intensity. Intensity of the light it can provide. Okay, measured in what? Measured in candela. Okay. Moving forward. Moving forward. Um, After these fundamental physical quantities, I'm going to skip the supplementary part for now. We are going to move to derived physical quantities. What are derived physical quantities? These are fundamentals and permutations of them are derived physical quantities. Okay. Permutations of fundamental physical quantities are derived physical quantities. Clear? That means like this. See here, here, area is length into width. Density is mass over volume. So these are permutations of these fundamental physical quantities, right? That means all other physical quantities in the world are, permutations of them. Okay, clear? You just combine them in different manner, then you get what? Then you get the derived physical quantities. Clear? Got the idea? I mean, what are the other examples? There's plenty of examples, right? Volume, volume, volume is length into length into length, right? Volume is length into length into length. Okay. Then there's thousands of them. Okay. Speed, 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 length over time, right? Speed is length over time. Okay. Then there's thousands of stuff like this. Okay. And you don't have to remember any of them. Why? In each lesson, you will learn these things. Okay. Now, what is the unit of volume then? Meters into meters into meters. So, meter cube. Meter cube. What is the speed? What is the speed? Speed is length over time, right? That means meters over seconds. That means meters per second. Here. That means meters per second. Like these, all these are what? Derived physical quantities. You don't have to remember them or their definitions. Why? There are separate lessons. In those separate lessons, you will learn about these derived physical quantities. Got the idea? Clear? So just know that there are derived physical quantities like this. Don't try to remember or study them. You will anyways remember them when you use them again and again in the syllabus. Okay? Ah. So after that, For some derived physical quantities, we give special names. Okay, there are some derived physical quantities that we give special names for them. What are they? What are they? For an example, take force. What is the derived physical quantity of force? Tell me a common equation related with force. F equals ma. F equals ma. So what is the unit of mass? Kilograms. What is the unit of acceleration? What is the unit of acceleration? Meters per second squared. Clear? Meters per second squared. Okay. Kilograms here, then meters per second squared here. Okay. Now you never write this unit. So this is the unit actually. Okay. This is the actual unit of force. Clear? Mass is measured in kilograms. Acceleration is measured in meters per second squared. So this should be the actual unit of force, but we never use this. What do we use? What do we use? Newton, right? Newton. That means this unit, we give a single name to this unit, that is Newtons, okay? We give a single name to this unit, that is Newtons, okay? Clear? So like that, there's plenty of derived physical quantities with a single name. Why? What is the reason? It's not convenient to use this again and again, right? Then if you write this 5 times, it's just a waste of time, right? So we give a single name for that. Again, what else? Pressure is measured in? Pressure is measured in what? Pressure is measured in pascals, right? Pressure is measured in pascals. What else? Energy is measured in? Energy is measured in joules. Energy is measured in joules. Okay. Frequency is measured in hertz. Frequency is measured in hertz. What else? Resistance is measured in, electric resistance is measured in ohms. Ohms. So all these are what? These are derived physical quantities with a single name. Okay. Derived physical quantities with a single name. And ideally all these are people. Okay. Clear? Newton is a person, Pascal is a person, Joule is a person, Hertz is a person, Ohms is a person. Okay. Clear? So ideally all of these names are given, were introduced to respect someone. Okay. Were introduced to respect someone. Clear? Okay. So that's about derived physical quantities. Go through the note and be familiar with the note in page 3 and 4. Go through the note and try to be familiar with the note. Go through the note. There's a table of different physical quantities. Okay. Just don't try to study that. Just know that. And if you have any questions, you can ask from invigilators. Okay. Okay, let's move forward. Let's move forward. The next one. The next one. Don't try to study them, okay? Don't try to study them. It's just a waste of time if you try to study them. You will anyways get to know them in different lessons. Okay? Then the next one. Next one is uh, there are some physical quantities without units. I mean, can you remember I just mentioned that? I mentioned that there are in any physical quantity there's a magnitude and a unit, right? In any physical quantity there's a magnitude and a unit, okay? But there are some physical quantities without units, but they don't have a unit as a result of the permutation, okay? They don't have a unit as a result of a permutation. So just because they don't have a unit doesn't mean that they are not physical quantities, okay? That means there can be some physical quantities without units. They don't have a unit because in the process of deriving that, units cancelled out. Only example you had in all your O-level syllabus is relative molecular mass, okay? Only example you had in your O-level syllabus is relative molecular mass, okay? Can you remember? It is a mass divided by a reference mass, right? Relative molecular mass is a mass divided by a reference mass, right? Yeah. So it can't have a unit. Another common one, you didn't had this in O levels, relative density. Relative density of something is density over density of water. Relative density of something is density over density of water. Okay. That is the relative density. Okay. Density over density of water. Clear? That is the relative density. Okay. So if it is relative density, okay, if you take this relative density, here you have the units of density, here you have the units of density, density into density cancels out, right? Clear? But still relative density is a physical quantity. Relative density is a physical quantity, but since it is, you get that by dividing two similar physical quantities, units cancel out. Clear? So physical quantities don't always have a unit. Okay? There can be physical quantities without unit as a result of the process of deriving them. Okay? Clear? So moving forward. Okay? So moving forward, uh, there's a bunch of physical quantities like that you can see in the page 5. Okay, on the page 5 you can see a bunch of physical quantities like the relative density, efficiency, coefficient of friction, refractive index, relative permittivity, relative permeability, relative humidity, strain. You don't have to worry of any of you don't have to worry about any of them, because anyways you would hate all these units. Okay, there are separate units in the syllabus that you will write this like 1,000 times. Okay, clear? There's a about joules, you have the work power energy lesson. About ampere, you have current electricity lesson. About ohm, you have current electricity lesson again. About luminous intensity, you have the lesson called light optics. About hertz, you have the waves and oscillations lesson. For everything, you have a lesson, okay, in A levels. It's 2.5 years of content, okay, a huge syllabus, okay. Huge means this is a massive syllabus, okay. When we are done with this, you will see like this is like 100 times than 100 times of all your O-level 9 subjects combined, right? You combine all your O-level 9 subjects, then you have a syllabus, huge syllabus. You multiply it by like 100 times, then you get the size of the A-level syllabus, okay? A-level physics syllabus only. Then you have 3 similar syllabus like that for 3 subjects, okay? That is the size of A-levels, okay? I mean, why do I always mention this? Because this is not easy, okay? If you try to do science for A levels, you have to give enough attention, okay? You have to give a huge attention, okay? Like අන්තිම මොහොතේ අර මොනවා හරි කරලා O level කොට දැම්මේ අර ඒ scene එකේ ඉන්න කට්ටිය, you fail definitely, okay? If you try to do that here, clear? That's why 1/3 of fails. Why? Nobody, I mean, the problem starts with the tuition industry actually. Tuition people are afraid that students may stop the class. So even they start very slow and smoothly. Okay, for the first few weeks, they do O-level stuff, teach how to do O-level maths. Then students won't stop the class. They would take A-level lightly. Then they will stay in the class forever. As a result, 1/3 of the students fail. Okay, so the main problem is again from the tuition people. Okay, we as a tuition industry is supporting that corruption. That is the problem. Okay, clear. But anyways, we can't correct these stuff. So in all your 3 subjects, check whether that's happening. Okay, if your A level teacher is not doing A level content yet, okay, taking you smoothly through O level content, if you understand everything explained in your other class, in any subject, if you understand everything explaining in your other class, if it is very much related with your O level content, that means you are still in a scam, okay? You are being taken through a smooth road so that you won't stop the class, okay? You are taken in a smooth road, so you are not struggling, so that you will forever stay in that class. Okay, that's the marketing strategy used here. Okay, clear. We don't actually care. Okay, I have money from my electronic company, so I don't care if all the students stop the class. Till I can live perfectly well. So I usually don't care whether you stay or stop the class. But the thing is that, okay, so if you're, that's why one of the students asked me how to find a good combined class. Only answer from my side is, if you can't understand a lot of stuff explained in your combined maths class, then it is a good combined maths class. Okay, if you understand everything perfectly in the combined maths class, then it's not a good combined maths class. Why? That means your brain is O levels. If you understand everything, that means your class is also O levels. So you are not never gonna do A levels with that class. But if you are struggling too much, none of the thing the person is speaking in the combined maths class you understand. You can't understand anything. You are struggling always. That means that is a proper A level class. Your brain is still O levels, so there's a lot to develop. But your class is providing you with that chance to develop. Okay, clear? So in science, all your 3 classes should provide you with the chance to develop. Okay, that means you should not understand around 30 to 40% of the content in the class. That's when you know that you are going to a proper science class. Okay, clear? Because your class teacher should provide you with allowance to improve. Okay, here there should be 40 to 30% of content that you are not understanding. So you go home and think. That's how your brain develops. Okay, that's why even in our classes we give that small paper that you can never do. Okay, there's a single page. Hope you got that. I mean, today you would understand everything because I'm skipping all those parts. Okay, those maths parts, additional paper, you can get them as recordings. I'll give you all the recordings. So that's why we do not related to physics. Okay, this duty is not related to physics. This page is not related to physics. It's just related to brain. Okay, because units and dimensions lesson, there's nothing for your brain. It's just a bunch of theory. But from day one, we should work on your brain. Okay, so that's why we have this one. Okay, clear? Like that, you should be struggling in your science class. That's when you know that you are going to a good science class. Okay, clear? Let's move forward. Let's move forward. There's another type. Okay, there's another type. Supplementary physical quantities. Supplementary physical quantities. Supplementary physical quantities are physical quantities that does not belong to any of the physical quantities, like fundamental or derived. Okay. Supplementary physical quantities is a type of physical quantities that do not belong to fundamental or derived. There are 2 supplementary physical quantities that we are going to learn in our syllabus. One is the plane angle. Plane angle means just the angle that we know. Okay, plane angle is just the angle we know. Okay, that is plane angle. So what was the unit you measured this? What was the unit that you used to measure this? in degrees, right? You used to measure angle in degrees, right? Clear? You used to measure the angle in degrees. Clear? But here, okay, but here, um, the official SI unit, and again, the students who joined late or came to the physical class late, watch the initial part of the recording, okay? Clear? Because I can't do a revision session for the revision session. Okay. So definitely watch the initial part of the recording. It's available as a YouTube live link in our YouTube channel anyways. So here, uh, this is, we used to measure this in degrees, but the official SI unit of plane angle is radians, okay? Official SI unit for the plane angle is radians, clear? It's measured in radians, okay? So how do we define radians? Radians is defined in a special way. Now, you know 30 degrees, 45 degrees, 60 degrees. About degrees, you have a common idea, right? But you don't have a good idea about the unit radian, right? Yeah. You don't have a very good idea about the unit radian. So we'll talk about the unit radian. Unit radian is defined using a circle, okay? Unit radian is defined using a circle. That means if there's a circle like this, if there's a circle like this, okay, if there's a circle like this, and if this angle, if the radius of the circle is r, if this angle creates a cut a part of s, part s, if this angle cuts a length s of the circumference, then the angle theta is defined as angle theta is defined as S over R, S over R radians. Clear? Angle theta is defined like S over R radians. Clear? Got the idea? Angle theta is defined as S over R radians. Okay? This is the definition of what? Radian, unit radian. Okay? This is the definition of unit radian. Clear? So, try this. Write 360 degrees, convert quickly. Take your book and convert 360 degrees, 180 degrees, 90 degrees, 60 degrees, 45 degrees, and 30 degrees into radians. 30 degrees into radians. Quickly convert them. Quickly convert them. I mean, you may not understand if you are entirely new, then try. Then try. But I'll explain it within a few minutes, okay? Okay. Uh, so how do we do this conversion? How do we do this conversion? There's a question about the definition again. Okay. There's a question about the definition again. It's quite simple. Okay. This is a way of representing the angle. Okay. This is a way of representing the angle using a circle. Okay. Using a circle. Okay. I mean, always angles are related with circles, right? Here, angles are always related with circles. So what we do is we get a circle and we mark that angle on the circle. Then it will acquire a certain length of the circle. That length of the circle divided by the radius of the circle, that is the angle in radians. Okay, clear? That is the angle in radians. Got the idea? S over R. Clear? That is the angle in radians. Clear? S over R. Got the idea? That means, for an example, for an example, uh, assume that this radius is 5 meters and this acquires a length of 7 meters. This acquires a length of 7 meters. Okay. Then what is this angle in the unit radian? Then this angle in the unit radian is theta equals S over R, which means 7 over 5. S over R means 7 over 5. Okay. 7 over 5 radians. Got the idea? Clear? That's the definition of that unit. Okay. That's the definition of that unit. Clear? How can I confirm? I mean, there's nothing to confirm. Okay. That's the definition of the unit. Clear? Okay. So these are definitions, direct definitions. I mean, every unit that you know has a definition like that, that you don't know. Okay. Kilogram, I don't have to define like this. Why? About a kilogram, you have a common sense. Meter, I don't have to define like that. Because about the meter, you have a common sense. But they have definition. Like what? Previously, the definitions were objects. That means there's, I can't remember the country, there's the SI headquarters. In SI headquarters, they had a block of 1 kilogram. That is the definition of kilogram. Okay. In SI headquarters, they have a block of standard kilogram. That is the kilogram. Clear? Then they sent samples of that kilograms throughout the world. Using that, everyone manufacture kilograms. Okay. The balance and everything. Then previously there was a rod of length 1 meter in the SI headquarters. That is 1 meter. Clear? That is the definition, nothing else. But they later identified that there's a problem with that. Why? If someone comes and steal that 1 meter, now you don't have a definition for 1 meter, right? Clear? Or if a missile comes and land on SI headquarters, now you don't have the definitions, okay? So it's a problem. So nowadays, they introduce the definitions again, okay? They introduce the definitions again such that they can be recreated using natural stuff. For an example, today, the definition of meter is explained using the light. Meter is defined like you get the distance traveled by light within a certain time. Okay. You get the distance traveled by light within 1 second. Yeah. You divide it by this value, that is 1 meter. Now it's defined like that. Not using a 1 meter rod. They have defined that using, I mean, there were different definitions throughout the time. But one thing is, you like get a, like, you let light move for a second or something like that. Clear? Then you divide it by a certain value, then you get 1 meter. What is good about this definition is, no matter what is the country, what is the planet, whether you are in the universe or not, nobody cares, velocity of light is same. So you can recreate the definition of meter, whatever happens, right? Here, you just have to know the definition, that's all. So nowadays, everything is defined like this, using natural stuff that never changes, okay? Natural stuff that never changes. So it's a different story. Here, like that, this is the definition of radians, okay? Here, they should have marked like they had the ability to place a small shape like this and place a small shape like this at the SI headquarters and call this 1 radian. But again the same problem, right? Yeah, again the same problem. They should have done this, right? They can place a small object like this at SI headquarters and they can call, okay, this is 1 radian. Use that. But the same problem occurs, right? Then the same problem occurs when you define things like that, right? If someone steals this, you don't have a radian anymore. Okay? Clear? Then anyone can change the radian. So you define it in a better mathematical way. How? Like this. Clear? Clear? So then how can I define 360 degrees? I asked you to start with 360 degrees with the because of a reason. Why? This is easy to find. This is easy to find. Why? So your last New Year before actual A levels is going to be ruined due to this fuel issue, right? Last New Year in the sense, yeah, that is the last New Year that you are capable of celebrating, okay? You are not going to celebrate next year's A levels, okay? By then you have you have understood the gravity of A levels. Now you are struggling. Now you start all over again. You find paper classes. You find different classes. Your term test marks are there. So now your parents know that you are not good at A levels. So you have to somehow struggle and improve your marks. By then you are in a storm, okay? So this is the last New Year that you are going to celebrate, okay? I mean, these 2 years going to look like that, okay? It's like 2 years of very extreme training. That's all. After that, your life is good again. If you do things properly. 2 years of extreme hard training. Okay. For an example, I can remember I was in the junior national team for wushu. Okay. So previously we practiced in school. Okay. We practiced in school, no big issue. Then we were selected to the junior national pool. In the junior national pool, the training is done by army. Okay. The people are crazy. Okay. That means they start training at 7 and continuously train until around 12 continuous. There are like 20 people in the pool, like 5-6 of them faint. Okay. For sure. Then they behave like they don't see them. Okay. I think that's how they are used to do training. Okay. I mean, we are kids by then, right? We are not the national team, we are the junior national team, okay? So, but like 5-6 people faint here and there, nobody cares. Let them be. Okay, we continue the training. And by 12, I'm talking about the first day experience. Then by 12, at 12, they said that, okay, now we are done. I mean, I was relieved. I was really close to faint, okay? Quickly be here by 12:15. Practice stopped at 12. Quickly be here by 12:15. And we are going to start the second session. I mean, everyone was almost dead, and any people that know science, any person that knows science knows that you can't have food within 15 minutes and start training again. Okay, then definitely you are going to die. Okay, you know, like when food is in the system, if you do a hard training, there's a possibility of you dying too. Okay, yeah. Then from 12:15 to evening 6:15, continuous training. After that training, school practice felt very easy. Okay, clear. I mean, after that training, I mean, previously school practice was really hard. We can't go to the class after practice, morning practice. I mean, every place on your body is hurting. It's very difficult. But after few months in the junior national pool, after that, I mean, life seems very easy. You don't feel anything, okay? Anyways, I think, I mean, like you are almost like a zombie. You can't feel anything when you go through that practice. Something similar here, okay? So when you go through the 2 years of A level, very hard practice, a lot of dedication, a lot of discipline. After that, whatever the work you have to do in your profession feels easy, okay? Not a big deal, okay? So that is the whole point of doing science for A levels, okay? You go through an extreme hard training for 2 years, then you're done. Then after that, since your threshold is up, any difficulty feels easy, okay? We just set your bar up. That's how it happens. So moving forward, 360 degrees. 360 degrees is a very easy thing to find. Why? 360 degrees means one full circle, right? 360 degrees means one full circle. Clear? It is one full circle. Clear? 360 degrees means one full circle. Okay? So, 360 degrees in radians. What is the definition of radians? S over R. Definition of radians is S over R. Okay? What is S for one full circle? What is S for one full circle if the radius is R? What is S for one full circle? 2 pi R, right? S for one full circle is 2 pi R, right? Clear? So value S for one full circle is 2 pi R. Clear? Value S for one full circle is 2 pi R. Clear? Then you get 2 pi R over R. Clear? 2 pi R over R. Clear? Value S for one full circle is 2 pi R divided by R. Got the idea? Then R cancels out. R cancels out. You get what? 2 pi radians. Clear? 2 pi radians. So 360 degrees equals 2 pi radians. Clear? 360 degrees equals what? 2 pi radians. Got the idea? Got the idea? So that is the idea here. Clear? So you know how to write 360 degrees in 2 pi in radians, right? It's 2 pi radians. Then you divide this by 2. 180 degrees equals what? Pi radians. Clear? Clear? 180 is equals pi radians. You divide both sides by 2. Okay? You divide both sides by 2. Clear? Then you can find 1 degree. How? 180 degrees means 1 degree into 180, right? Clear? 180 degrees means 1 degree into 180. Clear? It is 1 degree into 180. Clear? Equals pi radians. Equals pi radians. Clear? Then 1 degree is equal to what? 1 degree is equal to, you take this 180 here. You take this 180 here. So pi over 180 radians. 1 degree equals pi over 180 radians. Clear? So this is the definition of 1 degree then. This is 1 degree in radians. Clear? This is 1 degree in radians. Now you can find the rest, right? Quickly find them. Quickly find them. What are the angles I asked you to find? 30, 45, 60, 90. Let's quickly go through them and move forward with theory. Are we getting the, do you have to write the definitions in the paper? No, I mean, you won't get this kind of questions in the A-level paper, okay? Yeah. These are just common sense required for A-levels. Nobody asks questions from this content. Okay. It's just in a huge question. You have to use the unit radian. That's all. Clear? We are just learning the things required for A levels for now. That's all. Okay, so how do we get them? 90 degrees means 90 degrees means 90 into 1 degree. That means 90 into, this is 1 degree, right? This is 1 degree. Pi over 180, right? 90 into 1 degree, so pi over 180 radians. 1 degree I converted into radians. Then it is pi over 2 radians. Pi over 2 radians. Then the next one, 60 degrees. Next one, 60 degrees. 60 degrees means 60 into 1 degree, which means 60 into 1 degree means pi over 180, right? 1 degree means pi over 180. Pi over 180. So you get pi over 3. Pi over 3 radians. Pi over 3 radians. Okay. Pi over 3 radians. Then 45 and 30. 45 and 30. 45 means 45 degrees means 45 into 1 degree. 45 into 1 degree. That means 45 into 1 degree means pi over 180. Pi over 180 radians. Pi over 180 radians. Then we get what? Pi over 4 radians. 45 degrees means pi over 4 radians. Clear? 45 degrees means pi over 4 radians. Clear? Then next 30 degrees means 30 degrees means 30 into 1 degree. That means 30 into 1 degree means pi over 180 radians. Then we get pi over 6. When you solve this, pi over 6 radians. Pi over 6 radians. Clear? Let's move forward. Then the next topic. So we have we have defined all the types of physical quantities, okay? We have defined all the types of physical quantities by now, okay? Now we have to move forward. Now we have to move forward with shaping these SI units. What is shaping these SI units? Shaping these SI units means like you have a unit called meters. Sometimes this is too small, sometimes this is too large, right? If you try to measure the size of this pen using meters, you have to write point something, right? Here, you have to write point something, clear? Which is not convenient. 0.4 or 0.3 or 0.02 or. And again, if you try to measure the length of an atom using meters, you have to write 0.000000000 something into meters. Yeah. Again, not that convenient, right? Yeah. It's not that convenient. Okay. So as a result, again, if you try to measure the length between two planets using meters, it's a lot of meters, right? Clear? Huge amount of meters. Not that convenient. You have to write some kind of million or billion number of meters. So sometimes these SI units are too small to measure something or too large to measure something. Clear? So in that case, what we need is we need to shape it. Shape means we use prefix to do what? To change the size of the unit. Clear? We use multiples and submultiples for this. Multiples and submultiples for this. What are multiples? Oh, I think in the tute you have submultiples first, right? Yeah. What are submultiples? I'm only gonna write the common submultiples, but you have a table with everything, okay? On page 5, at the bottom part of page 5, go to the bottom part of page 5. You have a bunch of submultiples. So there you have I'm gonna write only the common stuff. 10 to the power minus 9, 10 to the power minus 6, 10 to the power minus 3, 10 to the power minus 2, 10 to the power minus 1, nano, micro, milli, centi, deci. Okay. So these are the common stuff that you're gonna use. So remember them. But remember in the sense you don't have to actually remember when you do few conversions. When you do few unit conversions, you will eventually remember them anyways. Okay. So the meaning of this is what is nanometers? Nanometers means 10 to the power minus 9 meters. That's all. Clear? So nano is just a symbol used for this. Okay. Clear? Since it is not very convenient to write 10 to the power minus 9, 10 to the power minus 9 again and again, we use a symbol for that. Clear? Like that. What is micrometers? Micrometers means 10 to the power minus 6 meters. What is millimeters? Millimeters means 10 to the power minus 3 meters. Centimeters, 10 to the power minus 2 meters. Decimeters, decimeters, 10 to the power minus 1 meters. Clear? Decimeters, 10 to the power minus 1 meters. Clear? Got the idea? Clear? Camera? 10 to the power minus 1 meters. Decimeters means 10 to the power minus 1 meters. Centimeters means 10 to the power minus 2 meters. Millimeters means 10 to the power minus 3 meters. Micrometer means 10 to the power minus 6 meters. Nanometers means 10 to the power minus 9 meters. Clear? Got the idea? Then comes the multiples. What are multiples? When you need to increase the size of a unit. For an example, we start with kilo, then we move to mega, then we move to giga, tera. Yes, sometimes you may have to use peta. Okay. So kilo means 10 to the power 3. Kilo means 10 to the power 3. Mega means 10 to the power 6. Giga means 10 to the power 9. Tera means 10 to the power 12. Peta means 10 to the power 15. 10 to the power 15. So that means kilometers means 10 to the power 3 meters. Megameters means 10 to the power 6 meters. Gigameters means 10 to the power 9 meters. Terameters means 10 to the power 12 meters. Petameters means 10 to the power 15 meters. Clear? Petameters means 10 to the power 15 meters. Clear? These are the unit conversions. 10 to the power 3, 6, 9, 12 and 15. Clear? These are the unit conversions. Clear? So, we have to be able to do these conversions quickly, okay? We should have the ability to do these conversions quickly. So quickly try to do these things. That means quickly try 10 to the power 5, 10 to the power 5 milliseconds. 10 to the power 5 milliseconds, okay, into seconds. 10 to the power 3 nanoseconds into seconds. 10 to the power 4 microseconds into milliseconds. 10 to the power 8 nanometers into micrometers. Do these conversions quickly. Do these conversions quickly. Quickly try to get them. 10 to the power 5 milliseconds into seconds, 10 to the power 3 nanoseconds into seconds, 10 to the power 4 microseconds into milliseconds, 10 to the power 8 nanometers into micrometers. How do we do them? 10 to the power 5 milliseconds. I just have to remove milli, right? I just have to remove milli. How? 10 to the power 5 milli means 10 to the power minus 3, right? Milli means 10 to the power minus 3. Okay. Seconds. Instead of milli, I write 10 to the power minus 3. That's all. Clear? Instead of milli, I write 10 to the power minus 3. Okay. Then I get 10 to the power this 5 minus 3 seconds. Clear? That's how you work with powers, right? 5 minus 3 seconds. That means 10 to the power 2 seconds. Clear? 10 to the power 2 seconds. Then the next one, 10 to the power 3 nanoseconds. 10 to the power 3 nanoseconds equals 10 to the power 3. What is nano? Nano is 10 to the power minus 9, right? Nano means 10 to the power minus 9. Clear? Nano means 10 to the power minus 9 seconds. Clear? 10 to the power 3 nanoseconds. Instead of nano, I write 10 to the power minus 9. Clear? You can replace nano by 10 to the power minus 9 and you can replace 10 to the power minus 9 by nano whenever you need. Okay? Clear? Then you solve this. 10 to the power 3 minus 9. 10 to the power 3 minus 9 equals 10 to the power minus 6 seconds. Minus 6 seconds. Then 10 to the power 4 microseconds. 10 to the power 4 microseconds. Quickly write this if you need to write anything. Quickly. And if you need to ask anything, just ask from my invigilators. So about classes, there was a question. There are only two main classes. On Tuesday evening, the main English medium class, full English medium class. And the other one is Sinhala English mixed class happening on today evening, Monday evening. Both are at from 3 to 6:30. Tuesday evening 3 to 6:30 we have the main English medium class, and the Sinhala and English mixed one is on Monday evening 3 to 6:30. And there is a plan to start the entirely online one soon, but we'll see about that. Okay, an entirely online class we are planning to start again, but still not confirmed. So the plans are not confirmed well. Okay, moving forward, 10 to the power 4 microseconds. So let's use this 10 to the power 4 microseconds into milliseconds. So how do we do the conversion here? 10 to the power 4 microseconds equals x number of milliseconds. We can write it like this, right? 10 to the power 4 microseconds equals x number of milliseconds. Clear? Then, I mean, we ideally expect you to do this by mind and write the answer directly. But for the moment, you can use steps like this, okay? But after like 1 or 2 months, we are not expecting you to write the steps. You just directly do the conversion, okay? That's what we expect at the end, okay? We need you to do you to be able to do the conversion directly. But for now, you can use steps, just for now, okay? So we write 10 to the power 4 microseconds in milliseconds. So we'll think that 10 to the power 4 microseconds is equal to x number of milliseconds, okay? Equals to x number of milliseconds. Then we can remove all the multiples and submultiples, okay? That means you write 10 to the power 4 micro means 10 to the power minus 6. Micro means 10 to the power minus 6. Equals x number of milli means 10 to the power minus 3. Milli means 10 to the power minus 3. Here we have seconds. Clear? Micro means 10 to the power minus 6. Milli means 10 to the power minus 3. Clear? Micro means 10 to the power minus 6. Milli means 10 to the power minus 3. Then both sides are seconds. Okay? Then x equals what? Then x equals, you solve this and get x. 10 to the power 4 into 10 to the power minus 6. You bring this 10 to the power minus 3 here. You bring this 10 to the power minus 3 here. Clear? Then you solve this and get the answer. 10 to the power 4 into 10 to the power minus 6. You take this up. Then you get 10 to the power 3. Okay, then you solve this. You get 10 to the power 4 minus 6 plus 3. 4 minus 6 plus 3. Then you get 10 to the power 1. You get 10 to the power 1. Clear? Clear? You get 10 to the power 1 like this. That is x. Clear? That is x value. So it is basically 10. Okay? 10 to the power 1 is 10. So that means 10 to the power 4 microseconds, 10 to the power 4 microseconds equals x number of milliseconds. Equals what? X number of milliseconds. X is 10 to the power 1. X is 10 to the power 1. 10 to the power 1 milliseconds. Clear? Got the idea? That's how we do the conversion, okay? That's how we do the conversion. Okay. So I'll let you try these conversions too. One was 10 to the power 8 nano. Some conversions like converting compound units, converting different complex units. We even didn't do that in the main class. So anyways, they will be done in the main class, okay? We just converted the basic units, okay? In the main class, still what we have done is we just converted the basic units. So I'm going to do only that part today. Okay, in the main classes, we'll continue to convert complex units, okay? Clear? So the next one I gave was, give it here if you need to write. 10 to the power 8 nanometers into micrometers. 10 to the power minus 6 micrometers into megameters. 5 milliseconds into gigaseconds. 10 micro Kelvin into nano kelvins. Quickly write this down. Quickly write this down and try to execute the steps. I'll teach properly from other 4 examples too. Okay. Why are we worried about these steps and all? Because when we move forward with mechanics and other complex lessons, we can do these things again. Okay. You have to be comfortable with all the conversions and everything by then. When we move into larger lessons, okay? These are not major lessons. Units and dimensions, measurements, these are not actual lessons. These are just giving the common sense required for A levels, okay? Then comes the real part, okay? Then comes the real issue. So for now, like try to be comfortable with these like fundamental conversions as fast as possible. I'll explain things again. So what I did was 10 to the power 4 microseconds, I need to convert into milliseconds. So I think 10 to the power 4 microseconds is equal to x number of milliseconds. Clear? Then I can't solve this because this side is micro, this side is milli. So I remove all these symbols. I convert them into numbers. Then micro means 10 to the power minus 6. Milli means 10 to the power minus 3. Then both sides are in seconds. So I can easily cross multiply and solve them after. Clear? So I keep x here and bring 10 to the power minus 3 here. Clear? I keep x here and bring 10 to the power minus 3 here. Okay? Then I solve this. How? 10 to the power 4, 10 to the power minus 6, and I bring this up. 10 to the power 3. Clear? 10 to the power 4, 10 to the power minus 6, 10 to the power minus 3. I take this up, converts into 10 to the power 3. Then I solve this. 4 minus 6 plus 3, which gives me 10 to the power 1. Clear? So x equals what? X equals 10 to the power 1. Clear? When you solve these powers like this, that becomes 10 to the power 1. 4 minus 6 plus 3. Then x is 10 to the power 1. So I put it here. 10 to the power 4 microseconds equals x number of milliseconds. What is x? It is 10 to the power 1. Clear? Now try these conversions. I'll give you the interval at the same time. Let's start around 10:30 maybe. Okay. Be here by 10:30. Be here around 10:30 and start doing these questions. Okay. Be here around 10:30 and start doing these questions. Online students, if you have any questions, mention in the chat. Okay. If you are done with all of these, you can try exercise 1 in the book. Okay. You can try exercise 1 in the book. And for anything, if you are not in the group or anything like that, send a message to this number. Or any issue, 070-154-6825. 070-154-6825. Send a message to this number. 070-154-6825. Send a message to this number if you are not in the group or if you need to join the group. Physical students can inform our invigilators and join the groups. Others, if you need the recordings, if you need to join the group or anything like that, send a message to this number. Take the interval quickly and be here and start doing these questions. Hope it's enough time to try these questions. Okay. So let's discuss the questions. So today I think there are issues related to buses, right? I think issues related to buses have started now. So if, as I mentioned, if things turn into online, anyways, I'm going to do things physically at CCG, okay? So you can come physically if you need. Okay, let's move forward. Let's do the questions. Let's do the questions. What are the conversions? 10 to the power 8 nanometers into micrometers. 10 to the power 8 nanometers. 10 to the power 8 nanometers. 10 to the power 8 nanometers into micrometers. So what are the steps? What are the steps? 10 to the power 8 nanometers equals x micrometers equals x micrometers. Then 10 to the power 8 nano means 10 to the power minus 9. Nano means 10 to the power minus 9 equals x. Micro means 10 to the power minus 6. Clear? 10 to the power 8. Nano means 10 to the power minus 9 meters. Micrometers means 10 to the power minus 6 meters. Clear? Clear? Then x equals 10 to the power 8 into 10 to the power minus 9 and you take it here. 10 to the power minus 6. So basically now you should, by now you should have understood that what is basically happening here is, you have the number multiplied by this prefix divided by this prefix, right? So you actually don't have to write steps, okay? Try to understand by yourself and remove steps, okay? You don't have to write steps for this, okay? So by the second question, you should understand what is basically happening is you have the number multiplied by this prefix divided by this prefix. Clear? Clear? By now you should understand that. Then in the second question, you write this and solve this. Clear? And in the third question, you try to do nothing and directly write the answer. Clear? That's how you evolve, okay? Clear? That's how you evolve. Got the idea? By now, by the second question, you understand 10 to the power 8 nano here divided by micro here. Clear? Next, as the next step, what you do is, okay? As the next step, what you do is you try to write the answer directly, okay? Clear? That's how things should happen, okay? So, 10 to the power 8, 10 to the power minus 9, you take this up. You take this up, 10 to the power 6. Here, 10 to the power 8, 10 to the power minus 9, you take this up, turns into 10 to the power 6. Okay, then what? 10 to the power 8 minus 9 plus 6. Okay, 8 minus 9 plus 6. Okay, then 10 to the power what? 5, right? 10 to the power 5, right? So we get 10 to the power 5. X equals 10 to the power 5. That means here 10 to the power 8 nanometers equals 10 to the power 8 nanometers equals x means 10 to the power 5 micrometers. So since now you understand this, next what you try to do is get that directly. Get that directly. How do you get that directly? Now you understand what is actually happening is this number here, this prefix here divided by this prefix, right? Here. So by the next question, you directly write that. You don't write this step here. By the next question, you don't write this. You directly write this value here, prefix in this side here, prefix in this side here. Clear? Then by the next question, you don't do anything. You try to do it in your mind and write the final answer. Clear? Like that, step by step, we try to move forward. Clear? Clear? In O levels, we were really careful about many steps. In A levels, we try to hand over as many as process as possible to your brain and remove steps. Clear? Clear? Why? Without a lot of steps, till a A-level question would go up to like 2 CR pages. Okay? Still without a lot of steps, an A-level essay question, you will have to write like 2 or 2.5 or 3 CR pages. So with all the steps, it will go up to 6 pages. Okay? Then you have to do 4 essay questions like that, 4 structured questions like that. Then you can publish a book on the A-level day. Okay? Like a 100-page book. Okay? Clear? So if we try to keep steps, okay, in A levels, if we try to keep steps, that's what happens. Okay? If we try to keep writing steps for these stuff, okay, then even without any of these steps, A level paper would take like 15 to 20 CR pages you will write within those 3 hours on A level day. If you write all these steps, you will write like 50 to 60 pages, right? Okay. Then it looks like a novel. Okay. Clear? So we can't do that. So in O levels, we were very careful about steps. Here, these are not steps. So we try to remove steps as much as possible. And if I can go from here to here directly, I go like that. Clear? Clear? That's what we try in A levels. Okay. We try to remove steps as much as possible and sharp our brain. Clear? Sharper the brain, less steps you should write. Clear? And towards A levels, we are going to get marking schemes, A level marking schemes, and study them and see what are the mandatory steps. But that's not the time for that. Okay, now this is not the time for that. Now what we are focusing on is making our brain sharp and remove as many steps as possible. Okay. So the next one, 10 to the power minus 6 micrometers. 10 to the power minus 6 micrometers. 10 to the power minus 6 micrometers into megameters. Into megameters. Into megameters. So, how can we do this? 10 to the power minus 6 micrometers. Now I'll write that directly then. Directly. So the value x is going to be what? Value x is going to be x equals 10 to the power minus 6. Micro means 10 to the power minus 6. Mega means 10 to the power 6. Clear? Now we write that directly. Clear? We remove one step at a time. See, this step and this step we remove them. Okay? This step and this step we remove them. Anyways, after this step, what you are getting is this value, nanometer, this value, micro, here. Clear? So we are going to remove these 2 steps now. Here. We are going to remove these 2 steps now and write this directly. 10 to the power minus 6. Micro means 10 to the power minus 6 again. Divided by mega. Mega means 10 to the power 6. Clear? Then we get 10 to the power minus 6. 10 to the power minus 6. You take this up. 10 to the power minus 6. Clear? Then we are going to get 10 to the power minus 18. 10 to the power minus 18. Okay, and by this Thursday, we are starting that session. to teach maths parts required for A levels. Okay, by this Thursday we are starting that project to teach maths parts required for A levels. Morning 8:30 to, as I'll provide the schedule in the group. I think 8 to 10:30 for English medium students. As I remember, 11 to 1:30 for Sinhala medium students. If you feel like joining that session, join the session to learn the required maths parts. And the main thing is like, if you're okay with mathematics, you don't have to join. We'll provide the syllabus in the group, okay? We'll provide the syllabus in the group. So if you're okay with maths, you don't have to worry about that. And the session may continue for a while until you're okay with the content, but session will happen physically and online both. But I think these days, joining physically is difficult, join online, okay? If joining physically these days is difficult, join online or watch the recording, okay? So the next one, so 10 to the power minus 18. So the answer is 10 to the power minus 6 micrometers equals 10 to the power minus 18, 10 to the power minus 18 megameters. Megameters. Next one. Five milliseconds into gigaseconds. 5 milliseconds into gigaseconds. 5 milliseconds, let's convert into gigaseconds. How? Yes, yeah. Anyways, gonna get the recording of that session. English medium online class is on Tuesday evening, 3 to 6:30. Full English medium one. Milliseconds into gigasecond. How? 5 milliseconds equals x gigaseconds. Okay. So actually no need to write the steps. X equals 5. I write milli here. Write milli here. Divide by giga here. Giga is 10 to the power 9, right? Milli is 10 to the power minus 3. You write it here. Divide by giga. 10 to the power 9. Clear? Then 5 into 10 to the power minus 3 into 10 to the power minus 9. 5 into 10 to the power minus 3 into 10 to the power minus 9. Then I get 5 into 10 to the power minus 12. 10 to the power minus 12. So we get the answer. How? 5 milliseconds. 5 milliseconds equals 5 into 10 to the power minus 12. 5 into 10 to the power minus 12 gigaseconds. 5 into 10 to the power minus 12 gigaseconds. Next one. Next one. 10 microkelvin into nanokelvin. We have to convert 10 microkelvin into nanokelvin. We'll do that. With here. Ask if you have any questions. Next one. 10 microkelvin into nanokelvin. Into nanokelvin. How? Again, 10 microkelvin equals X number of nanokelvin. That means 10 micro means 10 to the power minus 6 Kelvin. X nano means 10 to the power minus 9 Kelvin. Nano means 10 to the power minus 9 Kelvin. Then X equals 10 into 10 to the power minus 6 over 10 to the power minus 9, right? 10 into 10 to the power minus 6 over 10 to the power minus 9. Clear? Then we get 10 into 10 to the power minus 6 into, you take it here, 10 to the power 9. 10 into 10 to the power minus 6 into, you take it here, 10 to the power 9. Then 10 to the power 4. When you solve this, 9 plus 1, 10. 10 minus 6, 4, right? So you get 10 to the power 4. So 10 microkelvin equals 10 to the power 4 nanokelvin. Clear? 10 microkelvin equals 10 to the power 4 nanokelvin. Got the idea? Clear? Let's move forward. Let's move forward with theory. So this is basic unit conversions. There are much complex unit conversions. I still haven't done that in the main class either. So we'll do that in the main class next. Okay. So I'll move to the next part about SI units. Okay. Write down if I write anything quickly. Online students, mention if you have any questions. Okay. Let's move forward. Let's move forward. The next one is general features of SI units. Okay, these are basically common sense. Okay, we can call it the common sense about SI units. General features of SI units. What are general features of SI units? General features of SI units means how do we write SI units? The rules that we should follow when we are writing SI units. What are they? When you write a SI unit, okay, I mean, if a SI unit represents a scientist, okay, if a SI unit represents a scientist, it should be capital. Newton is capital, Pascal is capital, Kelvin is capital. These are people, okay? That's why. Then symbols can't have a plural form. It's just 5 kilogram, okay, not kilograms. Then this becomes kilogram seconds, okay? Then this becomes kilogram seconds, okay? You don't do that. If it is kilogram, it's just 5 kilograms, okay? Then moving forward, there should be a gap between the number and the unit. There should be a gap between the number and the unit. Clear? Then the next one, if we are using different units, there should be gap in between. That means 5 Newton meters. Newton is a unit, meter is a separate unit, right? So it should be written as Newton meters with a gap. Okay? It should be written as Newton meters. There should be a gap here. But the prefix, if you are writing the prefix, you don't use a gap. That means 5 nanometer, you don't use a gap, okay? 5 nanometer, you don't use a gap. Clear? 5 nanometer, you don't use a gap. 5 microseconds, you don't use a gap. Okay? Why? What is the reason for this? Otherwise, there will be a confusion. Where? Otherwise, is this 10 milliseconds or meter seconds? See? Otherwise, there will be a confusion in these kind of scenarios, right? Is this 10 milliseconds or 10 meters seconds? Clear? This can be meters and seconds or milliseconds, right? Both. Clear? Clear? So, if it is 10 meter seconds, it should be written like this, meters seconds. Clear? Clear? If it is milliseconds, it should be written as 10 milliseconds. See? That's when we need the gap. Otherwise, you may think, what is the point of these rules, right? See? When we don't have these rules, there's a possibility of confusion in these kind of scenarios, okay? Clear? There's a possibility of confusion. Now you know for sure this is millisecond, this is meter seconds, a derived physical quantity, meter second. Clear? And at the same time, like are we actually going to another thing? I said that milli means 10 to the power minus 3, right? I said that milli means 10 to the power minus 3, right? Clear? Milli is 10 to the power minus 3. So, can you write milli instead of 10 to the power minus 3 anywhere? No. You can't write 10 milli anywhere, okay? That means, for an example, this is 10 milliseconds. This is 10 milliseconds, okay? You can't just write it like this, okay? Okay? Milli is 10 to the power minus 3. It's true, okay? But you can't write it wherever you like, okay? Clear? Okay? This is 5 kilograms. You can't just write it as like this. Just because K means 10 to the power 3, it doesn't mean it written anywhere means 10 to the power 3, okay? Yes, K means 10 to the power 3. But you can't write it anywhere you like, okay? Clear? You can't write it anywhere you like. It should be written properly before the unit, okay? Clear? It should be written properly just before the unit. Got the idea? Clear? It should be written properly just before the unit. Got the idea? Clear? This is basically common sense, okay? This you know, okay? This you know. These stuff, did you ever follow these stuff until now? No, right? You didn't keep a space here. You didn't keep a space here. You actually didn't follow any of these, okay? You actually didn't follow any of these before in O levels, right? So are we going to follow them in A levels? Still no, okay? I mean, we don't have time to do these kind of stuff, okay? So they are just rules, okay? Just know them as rule. We are not going to do them, okay? Like any rule in the country, okay? Just like the rules we have in Sri Lanka, okay? You know them as rules, but you don't follow them, right? So the same scenario here, just know them as rules. Why? Why? If you are not going to follow them, why do we have to know them as rules? If it is a unit-based MCQ, they are giving you a MCQ, choose the unit written properly. For that question, you have to know them, okay? For MCQ like that. But when we are writing units in our questions, we don't have time to follow these stuff, okay? We don't have time to follow these stuff, so we just write them, okay? So if it is a unit-based MCQ only, these things matters, okay? Clear? If not, we don't care, okay? Clear? That is the idea. So that's the idea about SI units, okay? That's the idea about SI unit features or methods of expressing SI units, clear? Then there are relationships between units or features of units. Let's learn that part. There are features of units. What are these features of SI units? What are these features of SI units? So, do we have to by heart these prefixes? Anyways, you will remember with time, okay? You actually don't have to by heart this when you do enough questions. Okay, for now, just look at your tute from the table, just convert them, okay? Then with time, you will anyways remember them, okay? Meter, unit of velocity is meters per second. None of you guys studied that, right? Okay? Unit of velocity is meters per second. None of you guys studied that, right? It naturally happened, right? Like that, these things you will naturally remember, okay? So don't worry about remembering. For chemistry, bio, yes, you have to remember. For maths, physics, most of the stuff are natural, okay? With practice, you anyways remember them. For chemistry, you have to study, yes, okay? So with what lesson did you start chemistry? Structures, so something like that? Can't remember, yes, right? Yeah. I can't remember chemistry. I can't remember chemistry now. I actually don't like chemistry. Usually the subject you don't like, you perform well, okay? Because you work a bit. I mean, I hate chemistry, okay? But I had the chemistry prize at my school, Ananda College, for like all 2 years. And I think even in A levels, I had the chemistry prize at school. So, like, I still hate chemistry. I don't like chemistry, but I'm good at chemistry. Like that. Physics, yes. Physics, I used to learn mainly for, not only for A levels, for Olympiad. So that's why I had a proper base of physics, not only from A levels, okay? With only the knowledge of A level physics, it's quite difficult to teach in A levels, okay? You can't just teach in A levels just with the knowledge in A levels. You need something more to teach in A levels, because otherwise, if you all you know, all the physics you know is only from A levels, then it's a problem, right? And you don't know anything further, then we can't explain things very well, okay? But for other subjects, yes, so my knowledge especially for chemistry, okay, my knowledge comes from A levels only. But still, I'm good at that. I used to be good at that. Now I have no idea about chemistry. Okay, anyone doing IT? Anyone? Cool. There was a question about doing IT and chemistry. A common question occurs always. If you like IT or hate chemistry, yes, do IT. Only thing is you're going to miss engineering, joining engineering, but there's plenty of other ways to do engineering. So no worries about that. Only thing is you'll not be able to be a doctor, and you'll be not be able to get an engineering degree from a government university. You will miss these two. But nowadays there's plenty of degrees that you can do. AI, IT. Very good degrees with IT too. Okay. If you feel like you're not good at chemistry, if you hate chemistry or something like that, feel free to move to IT, but you're going to miss engineering kind of stuff, okay? Yeah, it's up to you. Okay. Uh, Next, general features of the units. What are the features of the units? Units cannot be added. Units cannot be added or subtracted. What is the meaning of that? You can't add meters with kilograms, right? You can't add 5 meters and 3 kilograms, right? Yeah, doesn't make sense, right? Kilograms can be added only with kilograms, right? Meters can be added only with meters, right? Yeah. So units should be same to add. Otherwise, you can't add units, okay? You can't subtract units, you can't add units, okay? Clear? You can't add units or you can't subtract units, clear? Then at the same time, but you can multiply and divide units, right? Clear? But you can multiply and divide units. Meters over seconds, meters per second. See? You can multiply Newton seconds, Newton seconds. Clear? You can multiply it or divide units, different units, but you can't add or subtract different units. Clear? Got the idea? Moving forward. If you take an equation like this, P equals Q plus R, units of all the terms should be equal, okay? That means for you to add these two, units of these two terms should be equal, right? Units of these two terms should be equal. If this is kilograms, this must be kilograms, right? If this is kilograms, this must be kilograms. Clear? Clear? Then if this is kilograms and this is kilograms, when you add them, you get again kilograms, right? When you add kilograms and kilograms, anyways, you get kilograms, right? So this is also kilograms then, right? Clear? That means in two sides of the equal sign, you should have the same units. I mean, 5 meters will not be equal to any number of kilograms, right? 3 seconds will not be equal to any number of meters, right? Clear? So, whatever the units in this side should be equal to the units in this side. So, as a result, when you have an equation like this, units of this term should be equal to the units of this term, should be equal to the units of this term. Clear? Units of all three terms should be equal. Got the idea? Then, some of the question we do today will be repeated in the next week's class or this Tuesday's and Monday's class a bit. Then after that, everything would be normal. You can move forward with the class without an issue. But the thing is, at this stage, we can do this easily, okay? It's only a 4-hour class. I mean, it's more than enough time to cover everything, okay? Yeah. But after a few months, it's a bit difficult process. But still, we will do that. We will need like 3-4 classes for that. But after 6-7 months, I can't do that, okay? After 6-7 months, I can't catch up you with the main class, okay? Then the main class is gone. You have to find a different class, okay? Clear? Or you can join the next batch, okay? So at this stage, yes, we can recover anything, okay? 2-3 months from now, yes, I can do 3-4 sessions and recover everything. After 6-7 months, I can't recover anything, okay? If you miss, you miss, that's all, clear? Okay. So don't miss classes in the future, okay? This relates to all 3 subjects, okay? And the main problem is that, I mean, in O levels, you miss one lesson, it has no relationship with the next lesson, right? All very small separate lessons, right? Clear? In A levels, you don't understand this lesson, you don't understand next lesson. If you don't understand these 2 lessons, you don't understand anything after that. So it just keeps accumulating, okay? It's accumulating. All the problems accumulate in A levels, okay? Clear? That's the nature of A level exam. The syllabus is designed like that, like a flow, okay? Like a flow. You need everything before for everything next, okay? So, next one. You can't have a unit at a power. That means you can't have units for a power. That means 5 to the power 10 kilograms is meaningless, okay? Clear? You can't have a power here. It is just 5 to the power. You can't have a unit here. If it is 5 to the power 10, it's just 5 to the power 10. That's all. Clear? Clear? That's all. So you can't have a unit here, okay? You can't have a unit here. So as an example, 10 to the power L x. If L is a length, what is x? It's 1 over length. It should be 1 over length. Why? You can't have a unit at a power. So if this is meters, this should be 1 over meters, then meters and 1 over meters will cancel out, right? Clear? If this is meters, this is 1 over meters, then meters and 1 over meters would cancel out, then we would get 10 to the power, then we would get just a number, right? Clear? Here you can't have a unit. Here you can't have a unit. So if L is meters, X should be 1 over meters. Clear? Clear? Then meters to 1 over meters will cancel out. Got the idea? Then take the log function. Take the log function. You can't have, take the log function. You can't put anything with a unit into the log function. Log x should be something unitless, okay? X should be unitless. You can't find log of anything with a, you can't find log of anything with a unit, okay? You can't find the log value of 10 kilograms, no. You can find the log of 10, you can find the log of 4, but you can't find the log of 4 kilograms, okay? So this term can't have a unit, got the idea? This term can't have a unit and it should not have a unit, clear? This term should not have a unit, got the idea? This term should not have a unit, okay? Then the next one. Then the next one. Then the next one. This term can't have a unit. And the result of log function is also unitless. That means the value you take from the logbook, that is just a number. It can't have a unit, okay? So these are features. That means a term called, something called log didn't exist, okay? In the world. Then people like, I mean, basically, log was defined by someone else. Every other maths part was defined by Newton, okay? As I mentioned, all the trigonometric identities you are learning in maths class these days, right? Sine, cos, tan, relationship between sine values, cos values, every trigonometric stuff by Newton. Everything related to motion by Newton. Differentiation, integration by Newton. Yeah. So basically in your mathematics, if it doesn't have a name of someone else, it's by Newton. That's how it. That means for an example, there's L'Hopital rule. It's by that person. We have things like that with the name of that person. If it doesn't have a name, it's by Newton usually. Okay, that's the impact the guy had on your math syllabus. So even these functions didn't exist. Okay, some mathematicians introduced these functions. So when they introduced these functions, they said what can you do and what can't you do. Okay, so when they were defining, they said, okay, you can't put anything with a unit into this. Okay, then they said you are not going to get a unit out of this. Clear? Clear? Then the next one, sine, cos, tan values can't have a unit. Sine theta can't have a unit. Cos theta can't have a unit. Tan theta can't have a unit. These things we have to teach you. Okay, why? These are features of that function. Okay, these things we have to teach. Because these are features of that function. This I don't have to teach, that you anyways understand, right? Why? What is sine theta? X, Y, Z. So sine theta is X over Z, right? Clear? Sine theta is X over Z. Clear? Sine theta means X over Z. Clear? So anyways, what is that? Length divided by length, right? Sine theta is X over Z. That means the length divided by length, right? So when you divide a length by another length, units cancel out, right? Length is measured in meters. Again, the length is measured in meters and length units cancel out. Clear? So sine theta result can't have a unit. Cos theta result can't have a unit. Tan theta result can't have a unit. Got the idea? Clear? So these are the basic features of units. Okay. Let's go to the exercise 2 of your book. Go to exercise 2 on your book and go from question 1 to 18 in order. Go from question 1 to 18 in order in exercise 2. Start from question 1, then move to 2, 3, 4, 5, 6, like that. Any questions, online students? log, sine, cosine have dimensions? No. It's also a no. Go to exercise 2. It's at the page 13 of your book. Page 13 of your book. Keep doing the questions and ask questions if you have any. I'll show you how to do 1 or 2 questions, then you will understand. But before that, ask if you have any questions from things we did until now. Ask if you have any questions. In A level, don't they give marks for the steps? Yes, they do give marks for the steps, but these are not steps, okay? Okay. The thing is, yes, there's a marking scheme. There are marks for the steps, okay? But these are not the steps that we are talking about, okay? Clear? If these are the steps, then that thing I said is going to happen, okay? You will be writing a novel, okay, within 3 hours of A-level paper. Clear? So these are not the steps, okay? These are just basics, okay? Converting units kind of stuff cannot be steps in A-levels. Steps are much complex in A-levels. That we are going to learn later. Okay. So let's do a few questions I'll explain you how to handle the question like this. First one, F equals MA. So you don't have to, and if you need the unit of something, you have a table in the last page of the tute. Okay. You have a table in the last page of the tute. If you need, you can use them. Okay. But I mean, even here, there's no actual steps that you should write. That means I can't tell that you should write this up to this point. I can't tell like that. If you just know how to put units here and there, then that's all. That's what we expect, okay? If you have a common sense about units, okay? If you can develop a common sense about units, that's what we expect, okay? So for an example, F equals MA, units of A. So F equals MA. What is the rule I'm going to use for this? Rule I'm going to use for this is units of this side of a equation should be equal to the units of this side of a equation, right? Clear? Units of this side of an equation should be equal to the units of this side of an equation. Clear? Clear? So that means force is measured in newtons, right? Force is measured in newtons. Clear? Mass is measured in kilograms. Mass is measured in kilograms. Clear? Then unit of acceleration I'll take as UA. Force is measured in newtons, mass is in kilograms. This is unit of A. Okay. Then we get unit of A equals newtons over kilogram. That means newtons per kilogram. Newtons per kilogram. Got the idea? Clear? You can use this. Or if you need, you know that Newton is a derived unit, right? You know that Newton is a derived unit. Clear? Writing this is enough for now, okay? Writing up to this point is enough for now, okay? But you know that Newton is a derived unit. So if you need to simplify, you can simplify further. What is Newton? Kilogram meters per second squared, right? Newton is kilogram meters per second squared. Okay. This is Newton means kilogram meters per second squared. Can you remember? Newton is a derived physical quantity. So it is a derived unit. You can even get this from the last page of the tute. Okay. Into kilogram minus 1. Here. Kilogram into kilogram minus 1. Okay. Then what happens? Then you have kilogram here, meters per second squared here. Kilogram minus 1 means 1 over kilograms, right? 1 over kilograms. Clear? 1 over kilograms. Okay. Then this kilogram and this kilogram cancels out. Got the idea? This kilogram and this kilogram cancels out. Okay. Then you get what? Meters per second squared. Meters per second squared. Camera. Meters per second squared. Okay. So both of these are valid. Okay. Both of these are valid. Because again, you are never going to get a question like this in A levels. Okay. It's just for the sake of A level questions. But these are not A level questions. Okay. In a A level question, they will give you a scenario with different units. So to continue solving the question, you will need unit conversions like this. Okay. Okay. So this is just about common sense related to A level questions, not A level questions. Okay. So just knowing how to move units here and there is enough. Okay. So this is a valid answer. And this is also a valid answer. Okay. Here, both are valid answers. Next. Next. Second one. Second one. S equals UT. S equals UT. Okay. S equals UT. So the question is unit of U. So I can tell units of this side is equal to the units of this side. Units of this side is meters. Units of this side is meters. Units of this side is meters. Unit of this side is unit of U into time is measured in seconds, right? Time is measured in seconds. Unit of this side is meters. Unit of this side is unit of U into time is measured in seconds. So the unit of U is meters over seconds. That means meters per second. Meters per second. Clear? Then the third one. Third one. P equals H rho G. 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 So, P is pressure, rho is density, G is gravitational acceleration. What is the unit of H? Okay. So, unit of H you know, right? Meters. Okay. Clear? But this time we may get that in different units. Why? They are not asking you to write the unit of H directly. You have to put units, other units here and there and find the unit of H. Okay. So, unit of this side is equal to the unit of this side. What is the unit of pressure? What is the unit of pressure? Main unit of pressure? Pascals, right? Can you remember? Main unit of pressure is pascals, right? That you had in all levels, right? Yes, right? So unit of pressure is pascals. Okay. Then equals here unit of H. Multiply it by what is the unit of density? Kilogram per meter cube, right? Unit of density is kilogram per meter cube. Can you remember? Unit of density is kilogram per meter cube. Kilogram per meter cube. Okay. What is the unit of G? G is an acceleration. What is the unit of an acceleration? Meters per second squared. Meters per second squared. Okay. Then unit of H equals, I'll keep pascals here. Divide by this and divide by this. Kilogram per meter cube and meters per second squared. Kilogram per meter cube and meters per second squared. Okay, clear? Then use all this and you get the answer. How? Pascals. Here kilogram, meter minus 3 and meter 1. Minus 3 and 1 becomes minus 2, right? Clear? Minus 3 and 1 becomes minus 2. Okay. Clear? Meter minus 3 and meter 1. Then S minus 2. S minus 2. Clear? Then you get, you take everything up. Pascals into, you take kilogram up. So you get per kilogram. You take this up. That becomes meter squared. You take S minus 2 up here. You take M minus 2 up, it becomes meter squared. You take S minus 2 up, that becomes S squared. That becomes S squared. Okay? Clear? So this is the answer. Okay? This is the answer. Clear? Or else, okay, you can use pascals and expand that and solve this further if you want. Okay? You can expand pascals and solve this further. How? Go to the last page of your tute. Go to the last page of your tute. So this is the unit of H. This is the unit of H, right? Yeah. Let's take this. Let's take this. And you have here what you have is, pascals over this, right? Here what you have is pascals over this. Clear? Kilogram M minus 2 S minus 2. Okay. Then in the last page, we are telling that go to the pressure. Pressure is measured in Newton per meter square. Can you see the 11th row? In the 11th row, you can see pressure is measured in Newton per meter square, right? Clear? So instead of Pascal, you can write Newton per meter squared and this kilogram meter minus 2 S minus 2. Clear? So this is also a correct answer. Okay? This is also a correct answer. Clear? Instead of Pascal, Pascal means pressure. In the table, 11th row, they are telling that pressure is measured in Newton per meter squared. Clear? So this is also a correct answer. Pressure can be measured in pascals or pressure can be written in Newton per meter squared. Okay? This is also a correct answer. Then this and this cancels out. This and this cancels out. Then I can tell what is Newton's? What is Newton's? Force. Newton's means force, right? Here, Newton's means force. Newtons or force is measured in kilograms per meters second squared, right? Kilograms meters per second squared. Where? 8th row of the table, last page. Last page, 8th row of the table. Kilogram meters per second squared. Clear? So if you like, instead of newtons, you can write what? Instead of newtons, you can write kilograms meters per second squared. Okay? Instead of newtons, you can write kilograms meters per second squared. Okay? Here. Then you get kilogram here, S minus 2. Then kilogram and kilogram cancel out, S minus 2 and S minus 2 cancels out. You are left with meters. Here. You are left with meters. And as a fact, you know that height is measured in meters, right? Clear? As a fact, you know that. Clear? So all these are correct answers, okay? All these are correct answers. You can write it as this, or you can get pascals and write it as newtons per meter squared. This is a correct answer. Clear? Then you can write newtons as this. Then this is also a correct answer. And when you solve this, you get this. This is also a correct answer. Clear? Clear? All of them are correct answers. Clear? Write this down. And let us know if you didn't understand anything. Write whatever you need. Why? Anyways, you are not going to get a question like this in A levels. So steps don't matter. Okay, steps don't matter. Just understanding how to work with units is, that's what important. Okay. What is important here is understand how to play around with units. Okay. Here. We are just learning tools. Okay. These are not actual questions that you are going to get in A levels. We are just learning tools related to A levels. That's all. Continue to other questions. Continue to other questions. Move forward with question 3, 4, 5, 6, 7. Try the questions, and online students, let me know if you need me to explain anything again. Others, keep doing the questions and finish the exercise. Heat is a energy, okay? Heat is a type of energy. Heat is a type of energy. And you don't have to use the table, okay? Use whatever the units you know. Okay? For energy, what is the unit you know? Joules. Okay? For energy, you know the unit called joules, right? So you don't have to use the table. Use the units that you know, okay? There's no required format for the answer, okay? There's no required format for the answer. Just do the calculations, that's all. Okay? So you don't have to use the table. Use the values that you know. Use the units that you know. Yeah, pi over 8. It is unitless. Pi is unitless. So the unit of pi, don't write anything. Unit of 8, you don't have to write anything, okay? Pi is just a number. 8 is just a number. So they are unitless. So when it comes to units, you can simply remove the numbers. Pi 5 is unitless. 8 is unitless, like that. Let's go to question 4. Let's go to question 4. Question 4 means F equals G M1 M2 M1 M2 over R squared. G M1 M2 over R squared. Okay, so the question is, what is the unit of G? So what is the units of this side is equal to the units of this side, right? Okay. Units of both sides of a equal mark is equal, right? Clear? So what is the unit of F? Newton. Unit of F is Newton. Clear? Equals, what is the unit of G? U, G. Unit of G is U, G. Unit of M, kilograms. Unit of M, kilograms. Again, unit of M, kilograms. Clear? Unit of R, R is measured in meters. Since it is R squared, it should be meter squared. Okay? So use all this, you get the answer. And there's one thing special here. Main SI unit of mass is kilograms. Can you remember? So it's a special case, okay? A unit with a prefix is the main SI unit of mass. Everything else was seconds, Kelvin, meters, candela, moles, okay? That's a special case. This is a special case. Main SI unit of mass is not grams, okay? It's a special case. Main unit of mass is not grams, it is kilograms, okay? Clear? That is a special case, okay? So, you solve this and get the answer. You take meter squared here, you have newtons here. You take meter squared here, then divide by these two. Kilogram squared. Kilogram into kilogram, kilogram squared. You divide by that. Clear? Newton meter squared, kilogram squared. Okay? Then we get Newton meter squared, kilogram minus 2. Okay? Newton meter squared, kilogram minus 2. Got the idea? Newton meter squared, kilograms minus 2. Okay? Next. 5. Question 5. Question 5. F equals 6 pi neta AV. F equals 6 pi neta AV. Okay, neta. It's a Greek letter. Okay, neta. So there's a question. I think it's required for a upcoming question. What is rate of flow of heat? It's there in one question, right? In one question, you have rate of flow of heat. So that means joules over time. Rate of heat means energy divided by time, right? Clear? Rate of something means you divide it by time. Clear? Rate of something means you divide it by time. So rate of heat means heat over time. That means joules over seconds. Okay. I think there's an online question. It's required for a upcoming question. So the question here is unit of neta. Unit of neta. So units of this side is equal to the units of this side. Units of this side is equal to the units of this side. What is the unit of force? Newton, right? Units of force is newtons. What is the unit of 6? 6 is just a number, unitless. So sometimes we just write it as 1, nothing, okay? Just to represent nothing, we write 1, just a number without a unit, okay? It brings no unit into the system, clear? We sometimes write it as 1, clear? And pi is just a number, okay? It's not pi, okay? It's pi, okay? These are Greek words, okay? Greek letters. So it's pi. So pi, again it's 1, clear? No unit, just a number, right? 3.14 something. Neta, unit of neta, u neta. Unit of neta that I have to find. A is a radius, right? A is mentioned as a radius, right? That means a length. That means length is measured in meters. Length is measured in meters. Then velocity, meters per second. Meters per second. Clear? Meters per second. Okay? Velocity, meters per second. So here I get newtons. Here unit of neta. Here meter squared per second. Meter squared per second. Then we get unit of neta equals newtons over meter squared per second. Newton over meter squared per second. Clear? Then we get Newton per meter squared, Newton per meter squared seconds. Seconds. Clear? Newton per meter squared seconds. Got the idea? Clear? We get Newton per meter squared into seconds when you solve this. U neta. Unit of neta. Clear? Unit of neta. Let's move forward. Question 6. Question 6. Quickly write this down. I mean, all these equations are not made up stuff, okay? This equation is there in the lesson, not the last lesson, the lesson before that, 10th lesson, properties of matter. All these equations this is from the gravitational fields, okay? Camera. This is from the gravitational fields, okay? This equation is Newton's gravitational law. This is Newton's gravitational law, okay? And this we call the universal gravitational constant. This is from the properties of matter lesson, 10th lesson. Like that, all these equations are all these equations are from the lessons that you are going to see in the future. So you don't have to remember anything because anyways you are going to meet these stuff, okay? Now, this is only an equation. When we finish that lesson, you would understand the equation, okay? What is the meaning of that? Even this is similar story. F equals Young's modulus that you don't know actually. A E over L. Okay. So what is the force? Force is measured in newtons. Force is measured in newtons. Unit of Y, I'll just write it as unit of Y. This is area, right? This is area. What is the unit of area? Meter squared. Unit of area is meter squared. Then unit of E extension means a length, right? Extension means a length. Again, meters. E is extension. E is a length. E is a length. Then L, again a length, right? L is the initial length. Whatever the length, if it is a length, it's in meters, right? Clear? Then you solve this. This and this cancel out. This is equal to newtons over meter squared. Newtons over meter squared. Then you get Newton per meter squared. Then you get Newton per meter squared. Clear? Question 7. For question 7, you may need the unit of a charge. Unit of a charge is coulombs. Coulombs. This is a person again. Use that and write the answer. Unit of a charge is coulombs. It's given in 26 row, last page, 26 row, coulombs, capital C. Capital C. Unit of a charge is coulombs. It is in capital C. Question 7. Question 7. F equals F equals, this is from static electricity lesson. 1 over 4 pi epsilon, 4 pi epsilon, this is epsilon. Don't try to remember them, okay? You will be used to them when we do that lesson, okay? 4 pi epsilon, Q1, Q2 over R squared, unit of epsilon. So unit of this side is equal to the units of this side, okay? Units of both sides are equal. So what is the unit of force? Unit of force is newtons, okay? Unit of force is newtons. Here 1 over, unit of 4 is 1. It doesn't have a unit. Unit of pi is 1. It doesn't have a unit. It's just a number. Then this is unit of epsilon, okay? This is unit of epsilon, clear? That we have to find. Unit of Q is a charge, is coulombs. Unit of Q is a charge, again coulombs. Here unit of R is a length, right? R is given as a length. So meter squared. So meter squared, clear? So you get unit of epsilon equals, I'll bring this here and we'll bring this here. I'll bring this here and this one here. So 1 over Newton, and here I get coulomb squared. Here I get meter squared. So I'm going to get coulomb squared per Newton per meter squared. Per meter squared. Coulomb squared per Newton per meter squared. Let's go to question 8. Let's move to question 8. Okay, let's move forward to question 8. Question 8. Q equals ms theta. Question 8. Q equals ms theta. Here, just keep it here. Now don't take another huge holiday for the new year, okay? You are anyways getting 1 week, okay? You will usually get a 1 week holiday. And do you have any idea about school starting days? No, right? Your results, results gonna be good, right? It's O levels. No one did bad at O levels, right? No, right? You can't do bad at O levels. It's easy, right? The difficulty is A levels, scholarships, then O levels. Scholarship is way more difficult than O levels. With that, relative to that age, there's a lot of thinking involved in scholarship. I can remember the different shapes kind of stuff. Sometimes still we can't do a scholarship paper. There are different shapes involved, and they're asking about leaves and all, which you have no idea by now, right? What is this leaf? Okay. I don't think that you would know that. The scholarship is way more difficult than O levels. O levels now after few months in A levels, you check the O level papers, they are quite easy. Not the history one and all, okay? The dumb stuff, okay? So history kind of stuff, yes, it's different. And yes, I did literature, again difficult. Even now I don't know how to write the literature paper. So, anyway. And you have practicals coming up, right? in April end. Some people said that last Tuesday they had practice for that and all. What the hell you have to practice for level? Practicals, you just go there and sing a song, right? Something like that, right? Okay. Don't skip A-level classes for O-level practicals, okay? Why? I mean, nobody cares. You can fail O-levels and still do A-levels very well. Okay. Question 8. Question 8. Q equals ms theta. Q equals ms theta. Let's try to convert this. Q equals ms theta. Q equals ms theta. Question 8. Q is the amount of heat, m is the mass, theta is the change in temperature. What is the unit of S? So, unit of this side is equal to the units of this side. So, unit of Q is joules. Unit of Q is joules. Unit of M is kilograms. Unit of M is kilograms. Unit of S is US. Unit of theta. Unit of theta. Theta is the change in temperature. Change in temperature means temperature, right? Even a change in temperature is a temperature, right? Clear? So even a change in temperature is a temperature. So you can write it is in Celsius or Kelvin, but the main fundamental unit that we are going to use is Kelvin, okay? The main fundamental unit that we are going to use is Kelvin, okay? Clear? So we can tell unit of S is equal to joules over kilograms over Kelvin, like this. Clear? Joules over kilograms over Kelvin. Clear? Clear? Then you get joules per kilogram, joules per kilogram per Kelvin. Clear? It's joules per kilogram per Kelvin. Okay? Okay? Joule per kilogram per Kelvin. Okay? And in the main class, if you have time, try this tute. Okay? I'm talking to new students. This is an entirely difficult tute. Okay? This extra tute, if you didn't receive that, request it from our people. It is an entirely difficult tute. Okay? So you may try the tute and you most probably will not be able to do at least one out of this tute. Okay? Yeah? That is the whole point of this tute. We have, I think in the main class, we have discussed like 4 questions of this. Every week I discuss 1 or 2 questions from this. And for the people who finished this tute, we gave another book with questions like this. Okay. So the whole point of this is in A levels, there are 2 sides. You have to learn the theory required for A levels. This is the theory required for A levels. Okay. And you need to have a certain level of intelligence to do science. Okay. Yeah. That is not anyways related with O levels. Okay. If you did well in O levels, that doesn't mean you are smart. Okay. You can just follow a set of instructions. That's a basic idea of O levels, right? For O levels, for anything you had steps, right? O level maths, O level science. For anything you have a bunch of steps. You execute the steps, you get the answer, right? Here, you execute the steps, you get the answer. So in O levels, intelligence is not involved. Okay, you don't need intelligence to do O levels. Nothing complex thinking is not there. If you know the steps very well, if you went to a good class, if the person taught you proper steps, if the person explained you enough questions, then you are going to do it well. For A levels, intelligence matters. Okay, intelligence matters for science actually. Okay, for A level science subjects, intelligence matters. Okay, So you should have a certain level of thinking that you never experienced in O levels. That means you have to understand a practical scenario and sometimes invent some new stuff for that question. Okay, you never invented anything for O levels, right? You just know the equation, you apply that, you get the answer. This is quite different. Okay, that's why this. So you can try this tute. Try this for a week. Sometimes you won't get any answer. Okay, and that's the whole point of this tute. You don't get any answer, but you still keep thinking. That exercises your brain. Okay, so even without you knowing, your thinking capacity will improve slowly. Okay, so that kind of a separate process happens in our class. Okay, a separate process happens in our class which is not included in the main syllabus. Okay, there's nothing related to intelligence in the main syllabus, but to do the A-level paper you need a lot of intelligence. So some kind of additional questions are done in the class. Okay, separate questions, additional questions are done in the class so that you can like exercise your thinking. Okay, clear? That is the idea. That is the reason for this tute paper, single page paper. So you may try this paper for few months. Still, sometimes you may not get any answer. But that process of thinking, okay, trying to come up with an answer, that process of thinking, that exercises your brain. Okay, clear? Got the idea? And that should happen in all three science classes. That means things that you can't understand, things that you have to struggle to understand should be there. Okay, yeah. Then only your intelligence grows. Okay, that is the whole point of doing science. Okay, after going through these 2 years, you get a certain value as a science student. That value is given to you not because of you learn these kind of dumb stuff. Okay, when you go to a workplace, no one's gonna ask you to convert kilometers into megameters. Okay, nobody cares. Okay, so why do they respect a science student? Due to the level of intelligence they have grown within the 2 years. Okay, so you have to work have to work hard on that. Okay, not the theory. Don't try to study these things. Okay, work hard on your intelligence. Okay, that's what matters. Okay, and that matters a lot. Clear? That matters a lot. Okay, keep these things in mind. Okay, so like the main theory points. Okay, main theory points required for to catch up the class, to move forward with the class from next week are done. Okay, by now these are the main theory points required to move forward with the class. Okay, but if possible, everyone join the group today. Online students, if you are not in the group, send a message to this number, not 701546825, not 701546825. And about tute delivery, we'll provide information in the group. Okay, quickly join the group today. Quickly join the group today. Then we'll provide tute delivery information in the group. In the group, we'll provide the tute delivery number. You have to send a message to that number with the information required. Then we'll deliver you the tute. Okay, and the next batch of tute delivery will also start soon. I'll inform then. Okay. We are trying to send the tutes required for next 2 months as fast as possible because we don't know when we may have to go for a lockdown or anything like that. Okay, we don't know when we will have to shift to online. And even the courier service have informed us that there may be a small delay in delivery due to the issues these days. Okay, so sorry about that, can't help. Okay, so like it used to be 3-4 days, now it may be 1 week or something like that at least due to the fuel related issues, but still the delivery would happen. Okay, tube delivery would happen, it would happen to continue. So request for the tubes, join the group and get the information and request for the tube. But anyways, you are getting all the PDFs for now. And in the physical class students, you can get all the tubes required. Okay, you can get the tubes required anyways. So mainly, and if there's any student who are joining physically today, but gonna continue online, request for the next tute too. Okay, others they will get in the class. If there's anyone who's gonna continue after today, if you are going to continue online forever, then get the next tute and go. Okay, then we don't have to deliver that. Okay, so that's about the class. So you can join tomorrow's class without any issue tomorrow evening, but after that don't miss classes. As I said, for 1 or 2 months we can do this. After that we can't do this. Okay, it's very difficult to catch up stuff. Okay, still we have done very small amount, so it's easy to catch up, but after that it becomes very difficult. Okay, so don't miss classes and request for the tutors and join the groups. This Thursday we are starting a process to teach mathematics to, especially for bio students, but even math students are not good at maths yet still now, right? You haven't learned a lot of maths yet. So even math students are welcome. If you like, you can join physically or online. Links will be available online. Yeah, and about online joining websites will be informed in the group. Okay, how to join online and about the websites required for that will inform in the group. So join the group. Okay, so that's all. So set up your website as soon as possible, online students. Okay, set up your websites as soon as possible. So that's all for today. Hope you understand things very well. And let's continue the class. Today evening, Sinhala and English mix class would happen. Tomorrow, full English class happens. And we have a plan of starting another full English online class, but we'll inform about that. Okay, still the plans are not sure. So join these 2 classes. Hope you understood everything very well. And if you have any questions, we have an invigilating program running in the class. You can ask questions from invigilators. There are 2 separate invigilating days. In these 2 invigilating days, you can either come physically and meet our invigilators, or you can join online through a Zoom session and contact our invigilators. There are 2 invigilating days happening in the class, and invigilating happens after the class 2 and before the class 2, and Thursday full day and Sunday full day are invigilating days. That means any subject, all 3 subjects you are doing, you can come to the institute and ask questions from our invigilators. Full day Thursday and full day Sunday for now. Still you may not have problems, but in the future you may have a lot of problems. Then you can use the invigilating program. You can come to the institute and ask questions from my invigilators on any subject. Okay, not only physics, on any subject. And for online students, in those days, there's a Zoom meeting running. We'll inform all the information. You can join the Zoom meeting and get all the support from the invigilators. Yeah, that's all. And thank you.